Okay, thank you. Can you hear me? All everybody hear me in the back. Thank you for coming. I was promising everybody there would be double-digit attendance, and we just made it. Um, I'm here to talk about. I'm Tom Siegfried. I'm here to talk about my book, The Number of the Heavens, which is about the history of the idea of the multiverse, meaning whether there's one universe or many. And that didn't work. Try it this way. There we go. I thought I would just start out quickly giving a quick run through about what do we mean by the universe today? What is today's conception of the universe? Because an important point of the book is that changes over time. Everybody at any given point in time in history of science thinks they knew what the universe was, but that doesn't stay the way the universe that what they thought it was wasn't what it turned out to be. So if you start out with the Earth, which is a big place, but not so big when you compare it with the solar system that's in part of. The Earth is, a little speck down in there that you can't even see. The solar system is one little speck in the Milky Way galaxy, which is down in that corner there. And you can keep going out like this and keep going out, and you think about each step is a massive amount of more space, and each previous thing is still a speck. There's the Milky Way galaxy is this little fuzzball, and there's a bunch of other these galaxies in the vicinity of the universe. And that bunch of galaxies is just part of a bigger supercluster of galaxies, and that supercluster is just part of a bunch of other superclusters of galaxies. So the universe we live in is this huge, huge space, and as we've known for quite a while now, it's an expanding space. The space keeps stretching out, and the distant superclusters appear to be flying away from each other because the space between them is expanding. This is still, these superclusters are still not the whole story. There's what we could see if our telescopes and went as far out as we could see. We get all these, and the last supercluster is a little spot among all these other things. So on the biggest scales, it's pretty much a bunch of big things. Now, so this is what today we think of as the universe, this big, huge space getting bigger with all these things in it. And a lot of people think that's the deal. Now we know. All those previous people thought what they thought the universe was is wrong. And that goes, but there are a number of scientists who believe that's not the whole story, that our universe is just one of many such spaces like that, and that would be what they refer to as the multiverse. Now, explaining how our universe got to be the way it is a tricky thing because it's so big and hard to understand and everything. But in early 1980s, some physicists and cosmologists worked out an idea that seems to explain a lot about why the universe looks the way it looks today. And that would be that right after the initial Big Bang that started everything going, there was a sudden, really rapid burst of a little patch of that space. And they call that rapid burst inflation. And that little patch got really suddenly bigger, and then it grew into the universe we have today. So we have what existed right after the Big Bang, a little bit of space in there, ballooned up into this, and today it's this. Now, that's a very nice picture, but if you work out the math, you realize if that is the correct explanation for what we see today, it wouldn't have happened just once. If it happened once, it could happen again. And that's what the theory, most people who work on the theory believe. It happened once, it happened again. So you have this spot going to this spot that makes this thing, but another little spot balloons up into this balloon, which makes another thing very much like it. And if that's true, and let me say, I don't know whether that's true, but it is what a lot of the best theories about how things look today implies. And it's not necessarily for sure, but it's a possibility. And it is a scientific question, no matter what else you might hear from certain other people. Uh, Andre Lindy, who's one of the pioneers of this theory, just put it this way, instead of the Big Bang was one in a sequence of bangs. The universe not only produces galaxies, it reproduces itself. And so that's the working idea today. And that's a big debate today about whether our universe is just the one or there are many of them in a multiverse. Now, Andre Lindy's picture of the multiverse is this, which I didn't think was such great artwork. So I commissioned a better piece of art by a famous artist named Ida Vigiani, who, by the way, tomorrow is her birthday, and she will be 7. But she captured the idea, a bunch of different universes, some connected, some disconnected, different colors indicating that different ones would have different properties, which is a really important point. If there is a multiverse, some of these other universes would be very much like ours, some of them would have very different properties from ours. So she also actually did this 3 years ago or so, so it's, not the work of a 7-year-old. But the point of my book is that this idea of many universes is not a new idea that occurred in the 1980s. It's a very old idea. Ever since people have been thinking about the universe, they've been thinking about whether there was more than one of them. So I'm going to show you a few examples of what ancient thinkers and people said, keeping in mind that in ancient and medieval times, they used the word world a lot, which was synonymous with universe, because they thought the world was the earth with some things, around it, circling it, and that was the world or the universe. All right. So Democritus, who is very famous for saying that everything is made of atoms, which was a novel idea in the 5th century BC, and there were Leucippus and Democritus and a handful of other people were really pushing this idea that everything was made of atoms. A part of that idea was that there would have to be, to make what we saw, the structure that we saw, an infinite number of atoms. And if there were actually an infinite number of atoms, after those atoms came together to make our world that we see, there would still be an infinite number of atoms left, and they would have to make a bunch of other worlds way beyond our world. And so that was the first really explicit multiverse idea. Now, one of the very famous later followers of the atomists was Epicurus, who was famous for a lot of interesting philosophy that applies to AAAS meetings. But he explicitly said there are infinite worlds, both like and unlike this world of ours. For atoms being an infinite number are born far out into space. Now, on the other side of the coin, Aristotle was adamant that there could not be more than one world. He believed he had demonstrated logically there could be only one world, and for Aristotle, if you didn't believe in his logic, he was very upset with you. And the heavens he talked about, Aristotle's world, was this set of spheres. The earth in the middle, with a bunch of spheres surrounding the earth that rotated around the earth. Each sphere had a planet, or the outer sphere had a bunch of stars hooked up to it. And that's why at night you look up in the sky, the stars seem to turn around the sky because it's a sphere, right? And so this was the picture of the universe that Aristotle imposed on the entire scholarly world for 1,500 years or so, and that was what everybody believed. Everybody bought Aristotle and disregarded what the atomists said about there being many universes. And this is in the 13th century. This was what people taught in the universities throughout Europe. The philosophers and theologians all taught that God had made the universe, and that was the whole shebang. That was it. And following Aristotle, Thomas Aquinas said it is necessary that all things should belong to one world. All these guys in this era, their whole job description was justifying Aristotle, okay, and explaining Aristotle and explaining why Aristotle was right about everything. However, in the year 1277, a landmark in the history of my story, the Bishop of Paris issued an edict there was talk in the church about some of the, theologians and philosophers, natural philosophers in these universities like Paris, teaching stuff that they didn't really believe was properly reconciled with religious teaching. So this bishop convened a panel of expert theologians, and they came up with this like 200 some things that weren't allowed to be taught anymore under penalty of excommunication. And number 34 was that the first cause, that would be God, could not make several worlds. In other words, if you were teaching that there was only one and could be only one, like Aristotle said, you were committing heresy and you were going to get excommunicated, which in those days was a bad thing. So, well, it just said, so all of a sudden, after 1277, all these philosophers started saying, well, now that we think about it, maybe there could be more than, maybe God made more than one universe. I mean, maybe not, we don't know, but he could have, right? And so there was, then the debate was whether he, not whether he could have, but did he or didn't he? And a lot of people said he could have, but he probably didn't. Others said no, they thought he might. And William of Ockham, the very famous philosopher, famous for his razor, was a real advocate of the idea that God could have made many, many such worlds. And that was, in this era, there was much more support for the idea of a multiverse. It was still an argument like it is today. Nicholas of Cusa thought the universe was not, like Aristotle said, one big set of spheres all encased by the sphere of stars, but the space extended indefinitely, and all through space there were world-like parts, like our world, like the old idea of universe. He thought there were an uncountable many of them. Now, Copernicus comes along and changes the whole deal a little bit, because now Copernicus says, no, the Earth isn't in the middle, the sun is in the middle, and the Earth is just another planet going around the sun, blah, blah, blah. So it changes the definition of universe from a set of spheres with the Earth in the middle to a set of spheres with the sun in the middle. But Copernicus maintained this outer sphere with stars stuck in this outer sphere, and that was the end of the world. So the whole universe was basically this solar system surrounded by a sphere of stars. So that's comparison of Aristotle and Copernicus. Now, a few decades later, a guy in England named Thomas Digges was translating Copernicus for people in England, and he redrew Copernicus's picture. And this is a really crucial point about the illustration of a deep idea, where Copernicus had the sphere of stars closing this all in. Outside of Digges's universe, there are all these other stars all the way hell out everywhere. It was like the stars reach up in spherical altitude without end. And that was the idea that influenced Giordano Bruno to come along and say that the universe is infinite with an infinite number of worlds like ours. If you think the solar system is the universe, there's an infinite number of such systems. So that would have been, in those days, what you would have conceived to be as a multiverse based on the previous definition of universe. This is an ongoing thing. Every time somebody says this is the universe and somebody says there are more than one, and they say, yeah, there are, well, then we have to change the definition of universe. So the definition of universe keeps changing every time. Now, after Bruno, at the time of Bruno saying this, Kepler, the very famous astronomer, disagreed and said, this is not science. There's way many million stars away the hell out there. We can't see them. They don't count. It's not science. And in fact, he said it's metaphysics, which is exactly what the people who don't like the multiverse idea today say. Oh, it's metaphysics because we can't see them. It's what Kepler said, and Kepler was totally, of course, wrong. Descartes, which is the source of the title, The Number of the Heavens, came along later. He thought that the sun was formed like as a vortex in space, and little planetary vortexes revolved around the big vortex, and that was our world, but that out in the vast space there were many other vortexes with many other stars surrounded by planets. And so he was another advocate for this multiplicity of what used to be a universe. My favorite science popularizer of all history was Bernard Lebovier de Fontenelle, who wrote a really fun book to read about the plurality of worlds when he speculated about other life on other stars and what life would be like and all this stuff. And um, he just really liked the idea, even though he could say, like I'm saying today, you can't prove it's true, but that doesn't mean you can't like the idea, right? Um, Huygens came along a little later, right after Fontenelle, and made this point, which is a really essential point, that our Earth is a speck of dirt. From the viewpoint of the cosmos as a whole, our Earth is a speck of dirt. And the greater part of creation is out of the reach of anybody's eye. Is that is the sort of thing that Kepler said, so it doesn't count. It's not science, metaphysics. And Huygens then went on to make this excellent point, though. To reason from what we see and are sure of to what we cannot is no false logic. We can see what we can see and then reason from that about what else must exist in order for us to see what we see. And this is the argument that Huygens made and turned out to be totally right about things at the time. It's the argument that people make today that, maybe take a few hundred years before they're shown to be wrong, but we'll see. But it's the key point. You can reason from what you see to infer things about what you cannot see. Kant then made the point. He's a famous philosopher, but especially earlier in his career, did a lot of stuff about astronomy and stuff. Well, maybe the solar systems, maybe there are a gazillion of these solar system universes, but it appears if you look out there that all these stars that might have planets are all congregated into one big thing, the Milky Way galaxy. And so that changed the definition of the universe again from the solar system being the universe to the Milky Way galaxy being the whole universe. And that made a lot of sense. And a lot of people, like William Herschel, took this up and did observations and constructed a picture of the Milky Way galaxy, which he got close to that. But, I mean, he didn't have space telescopes. And so people began to argue, though, about whether or not some of the little dots out there in space that were not like like stars, but they're like little fuzzballs. And so some people said, maybe those are other galaxies, other universes just far away, so they look like fuzzballs. And other people said, no, they're just fuzzballs. And there was, for 200 years, a huge debate about this. And one of the primary proponents of the island universe idea was Ormsby McKnight Mitchell, a famous astronomer who worked in Cincinnati and was a leader in making America a center of astronomy in the middle of the 19th century. Edgar Allan Poe was a big multiverse fan. And I had to put him in because he's in all my other books for one reason or another. And Edgar Allan Poe, following some of the things Kant said, I mean, you can imagine that not only are there clusters of universes like the Milky Way, there are clusters of such universes farther out from what we can see. And so the idea was really alive in the 19th century. But by the end of the 19th century, pretty much everybody had decided that the fuzzballs were, in fact, fuzzballs. They were little clouds. Okay? And some of them were, which is what confused people. But, and so, this nebulae as remote galaxies has been discarded. It's, the most probable hypothesis is that the star form one vast system. The Milky Way is the whole universe. But then in the 20th century, we had this rapid surge of advances. Henrietta Swan Leavitt figured out how you can calculate distances to distant stars, an enormous contribution to astronomy that was then used by Edwin Hubble to prove that the Andromeda Nebula out there, fuzzy as it might have first appeared, was actually a distant galaxy of its own, and that many others were. In fact, the island universe idea was right. The Milky Way as the universe was not the whole thing. There were many other such universes. You have to change the definition of universe once again. Well, that should have settled it right, because that would have been all that space has got all these galaxies. But no, when inflation came along and Alan Guth, the originator of the idea, said, it does. You have to take this idea seriously. That there are many, many of these universes like ours, if the theory of how ours got to be is correct. Um, but Skip just a lot of people don't like this idea. A lot of people don't like the idea that they can't see everything that's out there, and they don't like this theory because it predicts there's so many different realities out there that we could never contemplate. But as Steven Weinberg, the Nobel laureate, says, there's a lot of conditions we impose on our theories. We should not impose the condition that the theory makes us happy. That's not a good criterion for judging the validity of a theory, right? So the people who do not like the idea raise many other objections. They raise the objection that it's not a testable theory, and so it's not science. Other universes cannot be observed, and so they're not science. But for some reason, they are impervious to the responses to these arguments. I don't really know why, but the first one, the universe is not a theory to be tested. It is a prediction of other theories that can be tested. And it's just like with Einstein's. We've tested Einstein's general relativity in many ways shortly after it was first proposed. And it passed the test so well, we knew it had to be right theory. It also predicted gravitational waves. But there was no conceivable way in 1916 of seeing or detecting a gravitational wave. It blipped space by like amount of like a billionth the width of an atom. And people easily could say, that's impossible to observe, that it's ridiculous to consider that as science. And some people actually said stuff like that. But, 100 years later, you spend $1 billion and you invent lasers and stuff, and then you can do it. But those gravitational waves were out there before we built LIGO. So, they were scientific things. The idea that it's they can't be observed, well, you don't know they can't be observed. There are analyses that suggest another universe bumping into ours could make a little imprint on the cosmic microwave background radiation that is all through all of space, the leftover radiation from the Big Bang. And there's a little spot on one of these maps of the cosmic microwave background radiation that some people have suggested might be just such a sign. I don't think it is. I don't think many people think it is, but that's not the point. The point is, in principle, there could be a sign that we could see. So, it's not a testable theory. Testability is, an important part of science, but it's not the definition of everything that counts as science. You cannot say that some 20th century philosophers' ideas are the ultimate way of doing science forever and ever and ever. It's really a limiting notion on science, and it's not the way science is actually practiced by a lot of people today. And there's a lot of complications that you have to talk about that, because I don't mean that everything is science, but it's a limiting idea that you have to. It's not the whole story. And one of the lessons of all this is the right rules for doing science about the universe depend on what kind of universe we live in. If we really lived in a set of spheres that was closed off at the top, maybe a lot of Aristotle's ideas about how to do science wouldn't have been so bad. If we're in a multiverse, the rules for doing science are going to be different from the rules for doing science if there is only one universe. So people don't like a universe are kind of defining one universe into their set of rules for doing science from the outset rather than being open to the possibility. As this particle physicist Don Donahue points out, just because you feel bad about the multiverse and some aspects can't be tested doesn't mean it's wrong. There might be a multiverse, and to say there's is not science is itself not science. I just recently ran across an old book by Carlo Rovelli who expressed some of these points very well. Great advances in science not only are just great advances within accepted things, but they expand our worldview and expand our thought about what the rules are. If you fix the philosophy as fixed forever, that is betraying science's very nature. And so, I don't need to read all this whole things, but the idea that you have to limit science subverts our vision of the it limits science's ability to widen our vision of the world. So I want to leave a just a minute for questions, but I want to end up with James Hartle, who points out that the way the universe is, oh, man, this is a weird microphone. The way the universe is beyond our power to specify. There is no reason why the universe should limit itself to what some little blobs of protoplasm can test with what they've got to test them with today. And I think this kind of sums up the message of the book about this question of the multiverse. I don't know if there is, but it's a scientific question. So we have a couple minutes for questions, and then we can go over to the Harvard Press booth where we can ask more questions, and you can fight over the remaining few books they have to sell. Yes. Quantum many worlds theories. That's chapter 11. What I've been talking about is a very different kind of multiverse from the quantum many worlds. The quantum many worlds idea is that since quantum mechanics allows multiple different outcomes of observations and measurements, that when one is made, we see one, but the other branches off in another timeline. It's all kind of going on in the same space. You're only aware of the timeline and the branches that you stay on. That's a respectable idea. A lot of people are very much of the opinion that's the right explanation of quantum mechanics, and I'm not. I find it hard to believe, but I don't think you can rule it out. It's certainly a possibility, but it's a very different kind of multiverse from this bubbles of space that are booming up into existence with everything going. It's more a, branching tree that we are only on one branch, so that's all we know. Other questions? Yes? Well, I know scientific community is. Oh, yeah. What portion of the scientific community thinks this is bunk, and what portion thinks it's okay? Well, I think the whole science community is kind of irrelevant because you want to know people who know anything about it. Yeah, the relevant scientific community. Well, I can't put a number on that. That's like putting the number on the probability of finding extraterrestrial life, right? But I would just say that a large number of very prominent scientists of great accomplishment, Nobel laureates, people who have done groundbreaking work in their fields and are very well established, a large number of those people think the multiverse approach is a profitable line of research to pursue because it helps explain things that otherwise can't be explained. Now, there are many others who just poo-poo it and don't like it, but most of them haven't read my book yet. So, yeah, Robin. Right. Well, dark energy is the prime example of this, where we know that there is dark energy that is making the universe expand at an accelerating rate, or something is making it expand at an accelerating rate. So we call it dark energy without really knowing exactly what that is. Well, the mystery is, why is the amount of dark energy doing this just exactly what it is? Because if it was stronger, more dark energy, the universe would accelerate so fast we wouldn't have any stars or planets to form. We wouldn't be here. If it was too little dark energy or too low of the expansion rate of the universe, then it would all collapse before we get any stars and galaxies. So a lot of scientists would say they should come up with a theory that explains why that amount of dark energy is just that exact amount of dark energy. But none of the theories can explain that. If they try to explain it with a theory and they get an answer that's like 10 to the 100 power off the right answer. So, but if you have a multiverse and a whole bunch of different universes, each with a different amount of dark energy in it, there's going to be one where it is just right, and we will live in it, and that's the one we'll be in to ask the question. It's very similar to if there was only one planet around the sun, what are the odds would that planet be right in the right spot for there to be, nice weather somewhere other than here? And it's like, it would be a long shot, right? But if you got a whole bunch of planets out there, chances are one of them is going to be in the right spot, and that's why we live on that planet. There's no theory that says there has to be a planet right here. There's a theory that says if you make a bunch of planets, they'll spread themselves out at different distances, and one of them should be in the right place then. So that's one of the examples of what this idea can explain. If somebody came along with a great explanation for that question with a theory from first principles, then support for this idea would probably diminish a lot because, that people would be happier with that other explanation. All right, I think that's the end of the time. Thank you all for coming very much, and I'll go over to the Harvard Press booth.